So hello there and welcome to Electronic Technocrat. So today's tutorial will be part number 1 for the topic named as logic gates. Yes, so logic gates. This is one of the most important topic in the electronics history, or we can say logic gates are known as the heart of digital electronics. When we talk about a gate, in particular, what is a gate? So gate is an electronic device which can compute a function of a two-valued signal. Alright, so basically all the logic gates are the basic building blocks of all the circuits in the electronics part. Alright, so in general, when we talk about logic gates have one output, correct? One output and two inputs. I'm talking in general, so basically this is the fundamental of logic gates, that it has one output and two inputs. Alright, now there are some exception cases as well. One of the exception cases is the NOT gate. We'll come forward to this in the later part of the video. The NOT gate. This gate has got one output and one input. So this is the only exception case here. Alright, so generally we have got one output and two inputs in every logic gates. Alright, so the input of the logic gates are designed to receive only binary data. Now the computer students might know what exactly the word binary means here. Well, you guessed correct. Binary here means the data coded in zeros and ones. Correct. And this data is used in computer codes or computer language. The computer understands the language that is called as binary. Alright? It doesn't understand a robot language or human language or any other languages. It understands the language of ones and zeros. Alright? So the inputs of the logic gates, let it be any gate, let it be a NAND gate, an AND gate, an OR gate, or XOR gate, or NOR gate, or any gate. The inputs of these logic gates are designed to receive only the binary data, that is zeros and ones. So these two inputs will only receive the binary data. Alright, this is clear? Alright, the logic level low, that is capital LOW, represents 0 volts. Whenever I will use the word low, it represents 0 volts. And whenever I will say high, it will be 3 or 5 volts. Alright, so remember these terms. Whenever I will use a word known as low in the output, it will be 0 volts. And whenever I will use high in the output, it will be 3 or 5 volts, positive supply voltage. Alright, so we have got n number of logic gates in electronics, out of which we will be categorizing these logic gates into two parts. So the very first part that we will be categorizing, any guesses? You're correct. So it is simple diode logic gates. So I will be just I will be just using an abbreviation here, logic gates, or short form for logic gates. This is logic gates. Alright, and the second part is transistor logic gates. Alright, first one is simple diode logic gates and second one is transistor logic gates. Alright, simple diode logic gates that we are going to study will be divided into two parts in our video. The first part will contain the logic gate named as the OR gate, and the second part will contain the logic gate named as the AND gate. Alright, So why wasting time? Let's move on to the first gate, that is the OR gate. Alright, so first of all, when we talk about the OR gate, basically what is the first thing that comes in your mind? Exactly, it's a logic gate. Obviously it's a logic gate, but it's a simple logic gate. This gate is very fundamental in terms of electronic circuits. So you can say that these gates are very useful in making the other gates, such as the NOR gate. The AND gate is used for making the NAND gate. Alright, so these can be fundamental gates basically. Alright, so let's start our OR gates tutorial. So the first thing, the diagram that you see on the left here we go, this diagram. Basically this diagram is basically the diagram here that you see, that is this diagram, is the circuit design of the OR gate that is using the diodes. You're correct. This thing and this thing are the two inputs that are given to the gate, and this thing right here, this thing is the output. As I've said earlier, just right here, that any logic gate generally has one output and two inputs. So we've got a deal. So we've got this right. Alright, so now I'll show you, before going on to the working part, I will show you how exactly the logic symbol of OR gate is being shown. So the logic symbol, here we go, I'll write here. The logic symbol is represented as this diagram for the OR gate. So just pardon me, I just got some curvy lines here. It's not that curvy, alright? You can just ignore that. So two inputs X and Y and the output Z. Alright? This diagram is equivalent to this diagram. Only thing is that these two inputs have diodes in this. Alright? And we have got a output. Alright? So this is how you logically represent the logic gate called as the OR gate. Alright? So let's move on to the OR gate working. Along with that working, I will tell you the truth table as well. So I'll just make a column here, that is truth table. Alright, so let's start the working. Alright, so first of all, I will tell you the truth table. Alright, so the input side has got X and Y. Alright, so we got two inputs X and Y. We've got one output, that is Z. So we write it like this. We make three columns. Alright, so these two are the inputs and this is the output. Alright, so let's start it. So we start it as giving the prioritized condition or the normalized condition, that is 0 0. Then we go to 0 1. Then we go to 1 0, and in the last row we will write 1 1. Alright, so now let's go on to the working of this, and according to this we will fill this truth table. Alright, so as you can see in the diagram, now focus on the diagram right here. Alright, I have drawn the arrows as well. So just focus on the diagram and just visualize what is happening here. Alright, so the circuit design is shown here. This is the circuit design of the OR gate. This uses two diodes. Alright, as I've told you earlier, this uses two diodes in its input side. In all the logic gates, the plus 5 volt, listen very carefully, in all the logic gates, the plus 5 volt represents high logic level. Alright, and 0 volts represent low logic level. Just like this, what I've told you before. The low is represented as 0 volts and the high can be represented according to the circuit as 3 or 5. Alright, so let's go on to the circuit again. So any logic circuit, in all the logic circuits, in the fact, the 5 volt represents high logic level and the 0 volts represents low logic level. Alright, here 0, let me write it, 0 here means the switch is off condition basically, and 1 here means the switch is in on condition, or any circuit is in on condition. Alright, it's a very logical thing. Whenever you come across a term 0 or any value that is 0, that means the circuit is open, or we can say that the circuit is switched off. When we come across a binary number 1, that means the circuit is closed and the current is flowing, or vice versa, or we can say the circuit is on. Alright, so now let's go on to our truth table. As you can see, if we connect one high logic level to any of the inputs, what I am saying is, if this is 0, okay, so this is 0, and if this is 1, we will take the first condition. If this is 0 and if this is 1, what is the condition saying us? That one of the input is high and one of the input is low. Alright, so the working of OR gate says you that if one of the input is high and the other one is low, irrespective of anything, even if we have got one input as high and the other one is irrespective of that, the output will be 1, or we can say the output will be high. Alright, it doesn't matter what the output corresponding to this output will be. Alright, so when our first input here is 1 and the second input is 0, so again the condition comes that if one input is 1, that is high, and the second input is 0 or irrespective of anything, the output will again be 1. Alright, that is high. Perfect, you're getting it, right? You're getting the catch. That's good. So what did I told you? Just summarized. One of the input, if one of the input is 1, the output is equal to 1. Alright, did you get it? Alright, so if we connect, now I've told you about these two conditions. Now I will go to this condition and then I will come to this condition. If we connect two ones here, that is, if we give two out inputs the same logic level, that is high logic level, that is, if we give 1 to both the inputs, still we get an output that is 1, that is again high. You're correct, that is again high. Alright, so this is how the truth table of OR gate is working. No, I haven't finished yet. Yes, you're correct, you spotted it right. I have not filled this gap. So we have done with this condition, we have done with this condition, and we are done with this condition. Now we will go to this condition. Now question might be, or the question that you might be like imagining, like, what if we have given 1 1? Alright, so we have got 1. Alright, but what if both the inputs are 0? That's a correct question. Now if both the inputs, now according to the working of OR gate, what OR gate tells us that if I am giving 0 to both the inputs, I will get the output as 0. Now you will be thinking, how is this possible? How is this 0 and 1s are coming in the outputs? Alright, the simple reason, it is correct. You are getting a master. You're getting mastery here right now. So the condition for these outputs for getting 1s in their outputs is the forward bias condition. And why did we get this 0 here? This is because of the reverse bias condition. That's correct. Reverse bias. Alright. So what is a forward bias? Forward bias is basically that condition in a PN junction device which allows the device to flow a larger current. I'm talking about this. So which it is a simple arrangement basically in a PN junction device which allows a larger flow of current in only one direction. Remember this term, it only allows larger flow of current in one direction. Alright, and now you'll be wondering what exactly is reverse bias. Alright, so understood what is forward bias? I'm not going into detail about what is forward bias because it's a different topic in PN junction diodes. It's a different phenomenon. So I am just telling you in this context what exactly forward bias means and why did we get the outputs as the ones. Alright, and what is reverse bias? Exactly, you're correct. In reverse bias condition, what exactly happens is the DC voltage that is applied to this reverse bias condition, the current that is flowing through this reverse bias condition is completely blocked. You're correct. It's blocked. The current is blocked here. In reverse bias condition, the current doesn't flow at all. So that's why we get the output as 0. Alright. So when two inputs are 0, 0, we get an output as 0. And why is that so? And it is called as low, obviously. So why is it low? You're correct. It is low because of the reverse bias condition. Alright, so let's summarize it again. This is the logical symbol of how you're gonna represent a logic gate, that is OR gate. Alright, this is a circuit diagram of the OR gate. This is the truth table of your OR gate. Alright, so let's start from the first condition. If one of your input is 1 and the other one is 0, the output will always tend to be 1, that is high. If one of your input again is 1 and the other one is 0, the output will again be high. If one of your input, yes, you're correct, it's not one of the input now, it's when both the inputs are 1, 1, the output will again be 1, that is high. That is, these all outputs are corresponding to, yes, the forward bias state. You're correct. You are absolutely becoming a champion now. And the last condition is when both the inputs are 0, we get an output that is low. That is 0 basically. And why is it so? Perfect. That's because of the reverse bias condition. Perfect. So now we got everything understood right now. Now we are going to take a live example of this. Alright. So here we go. This is the live example of what we have studied as a OR gate. Alright. As you can see, we have connected a circuit basically. And that circuit has got a bulb here. Has got two switches around. And these two switches act as the inputs to the OR gate. Exactly. These two inputs. That is X and Y. You're perfect. So these are acting as the two inputs X and Y. And this bulb is the output Z. Alright. This is a real life example. Alright. So the first case, that is, what did I tell you? When we have got two same inputs that are zeros, what will we get in the output is reverse bias condition is applied and we get an output as 0. When we get one input as 1 and the other one as 0, we get an output that is 1. When we give one input as 0 and one input as 1, the output is again 1. And when we give both the inputs logic level high, that is 1, we get output as 1 again. So this condition is due to the reverse bias condition, short form. and these all conditions are due to the forward bias condition. Alright, so let's verify this truth table. I'm gonna change the color of the thing now. There we go. So the first condition is 0, 0. What is happening here? Both these switches are off. Now I will just give you a real life example here. Here we go. So both the switches are off here. So the bulb is off. Alright, this is the bulb. Alright. The second condition is when one of the switch is on. Here you can see one is on and one is off. Here both are off. Alright. One is on and one is off. We still get output. That is logic level high. That is 1. Alright. So one is off, or vice versa. One is on and one is off. We get an output. The bulb is glowing. Alright. In a third case, when one switch is off and one is on, we still get an output as 1. That is, when one switch is off and one switch is on, we still get an output that is 1. That is due to the, that is due to the forward bias condition. When both the switches are on, we get an output as on. So when both are on, we get output as on. Alright. So I hope that you got how exactly the OR gate is working here by this real life example. What I've done is this X input is your switch number 1 and the Y input is your switch number 2 and the Z is your bulb. Alright. According to the inputs that I'm giving via the switches, the bulb is acting to it. Alright. So again I'm summarizing it for you. If both the switches are completely off, we don't get any output. If one of the switch is on and one of the switch is off, we get an output. That is logic level high. That is 1. If one of the switch is again off and another is on, we get an output again. And if both the switches are on, we again get the bulb glowing. Alright. So this is all from my side. I hope you understood what exactly the OR gate means, and also I've given you a real life example too of how exactly the OR gate works. So this is the end of the part number 1. I will meet you at the start of the part number 2 with the new gate, that is the AND gate. Alright. So thank you very much and have a good day.